Hello, my name is Alvaro Polar, and I'm going to give a mini lecture about Introduction to Significant Figures. Yeah? I'm going to start giving the importance of significant figures. In order to do that, I'm just going to present a quick example of measuring an object. Okay? If I want to measure an object, a rectangular object like this, with a regular ruler in millimeters, okay, I measure the length, the width, the thickness, and the results I have here. The length 118.5 millimeters, the width 49.5 millimeters, the thickness 12.0 millimeters. Okay, and then I'm going to use another instrument to measure the same object, a vernier, and this instrument is going to give me a more precise measurements. And the measurements are already here. The length 119.03 millimeters, the width 49.98 millimeters, and the thickness 12.28. As you can see, the difference between the measurements of the two instruments are different. The vernier has one more decimal place in the measurement. Okay, so depending on the application where these measurements are going to be applied to, we can choose these measurements. We need to be more precise, or if the precision of the measurement with the ruler is good enough, so we will use that. So that all depends on the application. Okay, now all these measurements have a number of significant figures. Significant figures mean the digits that are very important in the measurement. They're very important and critical in that measurement. Depending on the application, we can use these measurements or with the vernier or the ruler. And as we're going to count the number of significant figures in each of those, the group, they're going to be different. For the width, using the vernier, I'm going to count 1, 2, 3, and 4 significant figures, 4 digits that are actually very important. For the length, I count 5. For the thickness, I count 4. On the ruler, here, the width has only 3 significant figures compared to 4 with the vernier. The length has 4 compared to 5 from the vernier. The thickness has 3 compared to 4. Okay, so significant figures is actually very important in science and engineering. Now, I'm going to give some rules how to determine the number of significant figures, because well, these numbers are pretty much easy to read, but there are some numbers where the zeros make a big difference. The zeros can be counted, the zeros are significant figures, the zeros cannot be counted as significant figures. So I'm going to start with just describing the rules. Number 1, all non-zero digits are significant. All non-zero digits. That's very important. For example, in the width, I have all non-zero digits. They are significant. I count 4. In the length, all non-zero digits, 1, 2, 3, and 4, but there's also a 0. But there's also another rule. Zeros between non-zero digits are also significant. So that's why in the length, I count the non-zero, and then this 0 is between non-zero digits. So it has to be significant. It is significant, I count 5 significant figures. Okay? Final zeros in decimal portions are significant. Actually here, the thickness using the ruler has 12.0. 12.0, even though it's the same number as 12, we can say same as 12.0, but 12.0 has 3 significant figures. 12 only has 2. What's the difference? Well, in this case, this reflects the precision of the instrument that has been used to measure this number. Okay? If that precision is important, we use it. If it's not important, we just use 12. In this case, there's 2 significant figures, there's 3 significant figures here. So we need to be able to identify the number of significant figures that are in the data that is provided to us in order to proceed with the science or engineering calculations. Okay? Now, that was number 3. Now, number 4. If a number has no decimal point, trailing zeros are not significant. I'm going to give you an example. The number 2000 doesn't have any decimal point. So, if a number has no decimal point, trailing zeros are not significant. So, in this case, these 3 zeros don't really count as significant figures. So, I only have one significant figure, which is 2. So, one significant figure. And I'm going to show you that it's only one significant figure by writing this in a different way. This 2000 can be written as 2 times 10 to the 3. That shows only one significant figure, one digit that is very important. 10 to the 3 is just that it's multiplied by 1,000. Okay? So, if the number 2000 will have a decimal point and a 0 after that, that means this number is going to have 1, 2, 3, 4, it's going to have 5 significant figures. Okay? This is going to be 5 significant figures. And I will not try to write this in the engineering notation. Okay? Now, the last rule, leading zeros in a number are not significant. I'm going to provide an example for that. Actually, I have room on the bottom. I'm going to write it here. The number that I chose is 0.00804. So the leading zeros in a number are not significant. Rule number 1, all non-zero digits are significant. Rule number 2, zeros between non-zero digits are significant. Therefore, I have 3 that follow number 1 and number 2. Okay, I have 3 so far. And rule number 5, leading zeros are not significant. These are the leading zeros. So these are not significant. So this is going to give me 3 significant figures. And also I can rewrite this number 0.00804 as 8.04 10 to the negative 3, which is the engineering notation, but it's exactly the same number. And here I actually seen only 3 significant figures. So it's a lot easier to see it here. Okay? So this is just an introduction to significant figures. Of course, it takes practice to identify what are the significant figures that are in every piece of the data that we are being provided to do the calculations. And when we do calculations, the final result is going to be always with the least number of significant figures that are being provided in the data. Okay? So I think this is it. Again, I'm going to repeat my name, Alvaro Polar. Thank you.